Greetings, friends. This is the second in our videos. Second video about t-tests and ANOVA. The first video we described the basic characteristics of t-tests, and we'll talk about ANOVAs here at the end of this video. But what we want to talk about in this one is a little bit more of the detail about how t-tests are constructed, and then also what can go wrong with them. And in finding out what can go wrong with them, we'll discover a little bit more about how they're used and what function that they serve. So remember we talked about how that t-tests are basically a description of the differences between two groups. So let's say we have a group here, group A we're going to call this, and then we sample another group and find out that there's this group B, and they have a statistically significant difference between the mean score. So let's just for a moment assume that in real life there is this group A and then there's this group B, and they are different in some kind of measurement. Don't know what that is. It's not important for our purposes here to know what the score is about, but whatever it was, this group A had a 70 and this group B had an 85. And we want to find out if that's a statistically significant difference. If we went ahead and sampled those groups, we'd get a nice even distribution. But let's say just out of sheer luck or dumb luck, in this group A here, we pulled a sample and all we did was we got these people. Now with mathematics, everything is possible. Remember that great line from Dumb and Dumber where one gentleman was talking to a woman completely out of his league and asked if there's a one in 10 chance, 1 in 20 chance. She kept saying no, and finally he asked if there was a 1 in a million chance, and she said, well, there's always a 1 in a million chance. And so he says, well, at least there's a chance. So you're saying that there's a chance. Well, there's always a chance that just about anything can happen. And it is possible that out of this group, where if you normally sample the group, the distribution would follow this bell curve, you may get just the folks that are on this end of the sample. And if that were the case, then what you would infer from your sampling was that there really wasn't much of a difference between the two groups when there really was a difference between the two groups. So we'll show that to you again. Here are the two groups. That's how they would exist in real life. You happen to sample them, and then your apparent sample would lead you, your sampling would apparently lead you to believe that these two groups are closer together than what they really were. That can happen. Or there could be two groups that in real life are very close to each other, but you happen to sample this group here and by chance only got those folks who were way out on this end of things, and so that would lead you to believe that there's more of a difference between the two groups than there really was. So we'll show that again. Two groups, there's not really any difference in real life, but your sampling of this group, you just happen to get the folks way out on that end. And so it showed you a difference between two groups that didn't really exist in real life. Now, SPSS, or the statisticians, have a way of determining what is the likelihood that the sample that you pulled that showed a difference could be just the result of chance. So what we in the social sciences require is that there can only be a 5% chance that what we saw just happened. There's only a 5% chance that the sampling difference is the result of chance. And that kind of certainty is what we will find acceptable in the social sciences. So if there's less than a 5% chance that the differences that we saw are a result of chance, we'll accept those findings. Now, it's not true in all aspects of research. In the hard sciences, the possibility that you found a difference that resulted from chance has to be less than 1 in 100, or 0.01. In medical testing, it has to be less than 1 in 1,000. And you can understand why. In medical testing, we're talking about people's lives and their health, and so you want to be very, very certain that the difference that you found as a result of some particular medical innovation is actually something that people can rely on, because there are complications with medicine, there are side effects, and so you want to make sure that the benefit outweighs the risk. In social sciences, I guess because the downside isn't as devastating, we accept a 5% chance. Actually, that's a 1 in 20 or a 5% chance. We will find that particular degree of uncertainty acceptable. So these are called type 1 and type 2 errors. And type 1 error is what's called a false positive. A type 2 error is called a false negative. A false positive means that there is, between the two groups, not a statistically significant difference, but because maybe you sampled and got more people who are on this side of the bell curve with this group 1, and on group 2 you got more people on this side of the curve, you found a difference when there really wasn't one. So we will accept the possibility that that might have happened, but only if the possibility is 5%. Same thing with a false negative. You might have sampled two groups on this side of the bell curve, found that they were statistically more alike than different, but in real life they were quite different, and you didn't find that. And that can happen. That's why important studies are often replicated and tried over and over again to make sure that the findings weren't the result of chance. So this certainty is called the confidence interval. We want to make sure that we want to state that we are 95% confident that the values that we are finding are actually there. They're actually a part of the population group that we are studying. Now that tells us the basic structure and what can go wrong with t-tests. And SPSS does a really nice job of calculating all that for us. One thing it doesn't do is it doesn't compute effect size, and you'll have to do that on your own. But it's a pretty easy calculation. All the numbers are there for you, and we'll show you that in just a moment here when we get to actually running some tests on SPSS. But basically, all you need to do to be able to compute the effect size, and we went over this last week, is to take the difference in the mean score or the average score between the two groups and divide that by the standard deviation. And again, we'll show you that in a little bit. But it's a pretty easy calculation to make. You'll see from the SPSS reports what the mean score of one group is and what the mean score of the other group is, and you just divide that by the standard deviation. And then you'll get that percentage of the standard deviation that a change in the difference in the two groups are. And that's an important statistic for us to be able to know and report when you're doing your study. When you're done with running the data sets on SPSS, you'll need to report those. And there's just this very simple 2-sentence description of the findings. Now remember, in qualitative research, our description of findings can take dozens of pages. In a t-test, and same thing with a correlation, the description of the findings is actually quite compact. And here is a template for you, and refers to the number of individuals in the sample, and M is the mean score. Remember, we talked about how it had to be less than a 5% chance. That's how that is expressed. P is less than 5%, and so back here at this, I probably should have pointed that out when we get back to this this description right here. That's called the p-value, and you want to make sure that for our purposes the p is less than 5%. So when we are describing the results of our t-test, when you're doing independent samples t-test, you will use this description. When you're doing paired samples, you will use this description. Now, we don't have a lot of time to go into ANOVA, but we don't really need to for right now, because all you need to know about ANOVA is that ANOVA is simply a t-test on more than two groups. Analysis of variance is the name for this kind of a measure. And in this illustration, we have 4 groups: north, south, east, and west, we're calling them. And what an ANOVA will do is compare all of these at once. Now you could run ANOVAs, t-tests, comparing north, south, northwest, north to east, south to west, south to east, west to east. And that would be 6 different t-tests. Well, ANOVAs will do all of that just at once. So with that completes the basic overview of t-tests and ANOVAs. We're going to now show you how to actually use SPSS to compute those.